Hi everyone, welcome to Compound Events. This is video concepts 3 and 4. We're going to do concept 3 as independent events, and then in concept 4 we're going to do another video with dependent events. So independent events. Now we're going to be talking about compound events, more than one, but this is going to be two or more simple events that are going to occur. Okay, so what we're going to do here is independent events is when the outcome of one event does not affect the outcome of another. Okay, so we're going to look at several examples of this. So our idea here is that when we're looking at independent events that are compound, we're going to take the probability of A times the probability of B, and if there was more than two events, you would keep multiplying like the probability of C here. Okay, so let's go ahead and look at several examples. A die is rolled 3 times. Now let's consider that die. It's a 6-sided die and it's equally weighted, so there's equal chance of getting any of the 6 digits. So what is the probability of getting 1s on each roll? Well, the probability of getting a 1, so the probability of rolling a 1 there is just 1 out of 6, okay? So the idea here is we're going to take 1/6 times 1/6 for the second roll, and if we roll that number cube again, there's still a 1 in 6 chance of getting rolling a 1. So that becomes a 1 out of 216 chance that you're going to roll all 1s. Notice that after I roll the number cube the first time, when I roll it again the second time, that first roll had no effect on what happened in the second event there. So that's what we mean by independent. Second example, a coin is tossed, then the day of the week is selected. What is the probability of getting tails then a day starting with the letter T? Okay, so when we think about this, the probability of flipping a coin equally weighted again is 1/2 for tails, right? There's only 2 sides. We want tails. The second event that's happening is we want to pick a day of the week that starts with T. Now there are 2 days that start with T. So it's either Tuesday or Thursday, so it's 2, and there are 7 days a week. Notice how picking the day of the week is not affected in any way by rolling or flipping the coin. So we get 2/14, which becomes 1/7. Okay, so the probability of flipping a coin that has tails and then picking a day of the week that starts with T is 1 out of 7. Okay? A couple more examples. Let's consider a bag contains 8 red crayons, 14 purple crayons, 6 yellow crayons, and 4 green crayons. A crayon is selected, replaced, and then another is selected. Find each probability. Okay, got to learn how to spell there. We misspelled there. Okay, so let's look at the probability of getting a purple, then a yellow. So the number of purple crayons is 14. Now, what's the total number of crayons that we have? If you take 8, 14, 6, 4, add those together, you get 32. So there's the total sample space. So there's our first probability. The probability of drawing a purple crayon is 14 out of 32. It is replaced, and then we got to find the next crayon. Okay, so the yellow. So yellow is 6. So you have 6 out of 32, and you're going to multiply those together. And then you end up, when you simplify this, is 21 over 256. That's the probability of first drawing a purple, then a yellow. All right, how about a green, then a red? So green, there are 4 crayons out of 32. And then you're going to replace that crayon. And what's the probability of then drawing a red? A red crayon, there are 8, so that's 8 out of 32. Okay? And so that probability is going to simplify down into 1 over 32. Okay, so you multiply that. We can simplify that ahead of time or just multiply and simplify. All right, now the probability of purple, then a purple. Well, the probability of purple is 14 out of 32. You put that back, and then you multiply it again, 14 out of 32. Now, we're putting that crayon back, and that's really important because that won't affect what's happening to the second time we draw a crayon out of the bag. So we have 14 30-seconds times 14 30-seconds, which ends up being 49 out of 256 when you simplify that down. Okay, and our last problem on independence, again, similar to 2 purples, we're going to draw 2 yellows. 2 yellows, you get 6 out of 32, which you could simplify times 6 out of 32 because it's 2 yellows with replacement. And when you multiply those out, you can simplify that into being 9 over 256. So that's the probability that you're going to pick 2 yellow crayons out with replacement. So that's all the examples I have on independent events. If you guys have any questions or comments, you can go ahead and type them below, and we'll see you next time.